Hey everybody, Big J, Anderson Mountain View Farm. Shift on the camera, say hey.
Hi.
Now, last episode we talked about is it divisible by and how it's going to help you out and how to use this stuff. So we're actually look at some of the first examples here. Is it divisible by? Let's take a number 1, 2, 4, 0. Now, is it divisible by 2? That one's pretty easy, right? If it's an even number, we know. That takes care of all the even numbers. It's divisible by 2, right? 0, if this number was, 1, 2, 4, 8, yep, we know. But let's look at it and say, is it divisible by 3? Okay, so this is how you do this. I'm going to put an equal to sign here. 1 plus 2 plus 4 plus 0. And that's going to give us what? 1, 2, 3, 3, and 4 is 7. 7 is not a multiple of 3. So, 7 is not a multiple, I'll abbreviate here, of 3. So, if the number, when you add up all the digits, if it's not divisible by 3, then you know it's multiple, then it's not. So I'll prove it to you here. If we take this number here, 1, 2, 4, 0, and we divide by 3, we get something like 413.333, which is 413 and 1/3, right? So there you go. Now let's try another number. And that one you can see, well, it's divisible by 2, so I can kind of work that down the factor tree, right? Let's try one that might be a thorn in your flesh. 1, 2, 4, 7. You're like, well, that's definitely not divisible by 2 or any other even number for that matter. So now it's like, okay, is it going to be divisible by 3? So we add it up. 1 plus 2 plus 4 plus 7. And so that gives us 1 and 2 is 3, 3 and 4 is 7. 7 and 7 is 14. If you divide that out, 1, 2, 4, 7 divided by 3, and you get something like 415 2/3. So 415 2/3, which is 415.666. So yeah, 1, 2, 4, 7 divided by 3, 415 2/3. So we know it right off. It's not divisible by 2, and it's not divisible by 3, or a multiple of 3, or a multiple of 2, right, even number. Then we may be dealing with one of those hairy things called a prime number. Or if it's not a prime number, does it have a couple of factors that are prime numbers? Okay, so let's work that out just a little bit. When you look at some of the prime numbers and you start plugging them in, all right, this number 1, 2, 4, 7, if you look at prime numbers like 7, 11, 13, and you just kind of start working through some of them, eventually, it won't take very long, you will get to, keep working yourself up, and you do 1, 2, 4, 7 divided by 29, 1, 2, 4, 7 divided by 29, so 1, 2, 4, 7 divided by 29, and you get 43. And, not surprising, 43 is also a prime number. Now what you'll notice here is 29 and 43, they start what we call converge. Now as these numbers start to converge, 29 and 40, as you're working through trying to figure out if it's a prime number, if you divide it, say divide it by 7, 1, 2, 4, 7 divided by 7, you're going to get something like 178 point, whatever. But as you get closer and you're working through these prime numbers, if you get to a point where now you try 31 and you keep going and it's not there, eventually these numbers are going to meet and then they're going to cross over, then you know, hey, I got a prime number. It's not divisible by anything, right? As you start to work through these. So, but in this case, it is not a prime number. But you were able to eliminate a lot right off because you had this right here going on. So it really helps you with stuff like that, some of the big numbers. So let's do one more number here. I'll do 530 13. So 5 plus 1 plus 3. So we've got what, 6 and 3 are 9, right? 5 plus 1 and 3. And so you're looking at it and saying, well, hey, I know it's not an even number. And so now I want to see, is 513, is that one of those weird like prime numbers? It's not looking, quite right. Let's see what's going on with it. So, and again, if I take the calculator out, 513 divided by 3, and the answer is 171. So there you go. So I better do it like this, 171. So what you thought initially might have looked like, oh, that's one of those prime numbers, I'm done, factor tree. Let's try it, do this right here. So instead of sitting there trying to divide by this, divide by that, and you're sitting there all day trying to figure it out, this sped the whole thing up. 5 plus 1 plus 3 equals 9. So I know it's at least divisible by 3. It might have been divisible by other multiples of 3 also. But I know it's at least divisible by 3. And I get this 171 number, and then I can kind of keep working myself from there too. Actually, the number 171, when you add all of that up, 1 plus 7 plus 1 is 9, so that's also going to be divisible by 3. So 171 divided by 3 again, and then that gives me, say divided by 3, that gives me 57. So technically it would be what? 3 times 3 times 57 would give me 513, and then and I can actually keep going down one more time, because 5 and 7 is 12, and if I do that, what, 57 divided by 3 is of course 19. So now divide by 3, I'm at 19. 19 is a prime number. So that's how I did that. I started there, worked my way down, okay? Because even some of these numbers, like 57, you're like, well, that's not a super big number, but what is that again? And you kind of you start to get into those weird numbers that might be, is it a prime number? Is it not? You can double check yourself real quick and say, oh yeah, 5 and 7 is 12, yeah. That's right, yeah. And then you divide it out and you get 19, you see? So that's how that helps out. Some of these prime numbers can get squirrely, and this will kind of help you get through that. Now, in the next episode, we're going to look at is it divisible by 6. Not doing all these in sequence, but you'll see why I'm doing that, because 6 is very much related to 2 and 3. So next episode, is it divisible by 6? Enter us from mountainviewfarms.com, like us on Facebook, subscribe to our YouTube channel, and we'll see you next time.